Hi to my science students. This is Mrs. Sturgeon, and I am coming at you with a topographic maps help aid. We are going to be taking a look at topographic maps 1.05 part 1 and 1.05 part 2 in detail. This is another help video to get you guys through those labs with a better grade. If you've already submitted yours, you've gotten a grade, but you don't like what you see, this is an opportunity for you to go back, revise, resubmit, and grab some more points. Okay, so here we go. We're going to take a really close look at a profile of a topographic map. I do have these links. They'll be in the email with this recording. You can also find them in the Relax Help is Here lesson in Unit 1. It's the first thing underneath Unit 1. This right here is our topographic map. Okay, these lines are contour lines, and they represent places with equal elevation. Okay, so anywhere on this line is going to be, if we follow it around, it will be 20. This could be 20 meters, 20 kilometers, 20 miles, whatever the designation is, it's 20. When we come out here, this is 10. So everywhere on this line is worth 10 meters, miles, kilometers, so on. And as we come out and our contour lines get larger, they're generally lower in elevation. And the further we go in towards the center of a topographic map, the smaller the contour lines get. So the circles get smaller, they get tinier and tinier, and then the elevation is getting higher. So this one here, for instance, everything here is 50 miles, 50 meters, or so on. So each contour line is representing a height above sea level. Where the ocean meets land, we call that sea level. And we reference that at 0. It's 0 meters, 0 kilometers. So then going under the sea, that's below sea level, things get negative. If we go on to land and start heading inland, then we're probably going up in elevation, and then we would be above sea level. So we might be 1 mile above sea level, and so on. If we make a graph that shows the height above sea level, we can use those contour lines to make a picture of what the landscape looks like. So this right here is our profile graph, and what we've done is I said we're going to hike across this island from point A to point B, okay? And then anywhere that this path meets a contour line, we'll bring a vertical line down to our graph at the proper elevation. So this contour line is 20, so we would bring this line down to 20. And then if we keep hiking, we get to this, we would bring this vertical line down to 30. And so on and so forth until we get in a picture of what the landscape would look like if we had stepped back and looked at it, looked backwards at it. So when we look at, when we look at a contour map, then that's like if we're up in a helicopter looking down on the landscape. And when we have a profile, it's like we've landed the helicopter and looked back at the landscape. So the contour map itself is like a helicopter view. The profile is like a horizon view. And so again, this, when we do this, we draw lines from the contour lines to the correct height on the graph. And that's our profile, or that side view picture of the landscape. Okay, so we're going to take a look again at this in a few minutes, all right? But just to give you this overview, this quick thought of what we're looking at. Okay, so we have these different profiles here, okay? And then we have these topographic maps up here. And east to west, if we look here, this is a compass rose, and east to west is side to side, okay? And we're going to move these matching, or these east and west profiles to the topographic maps, okay? And then we have some north-south profiles that we can move also. When we look at a topographic map, we have some lines that are way spread out, and then we have some that are very close together. When the lines are further apart on a topographic map, that means this is a more gentle slope. It's taking longer to get to a new height from here to here than it is over here. So these are closer together because we go up in elevation faster. And these are more gentle slope because it takes longer to get anywhere up in elevation. Okay. And so if we take a look at our topographic maps, we can see this hill right here is not going to be very high. This one is going to be much higher. We know that because of the number of contour lines and how close these are together, and these are much further apart. So we've got this nice gentle rise to a low hill, and then sort of a valley, and then up to a larger hill, a steeper hill. So this would be what we would be looking for down here. And if we look, we can see this right here, our east to west profile. See how that matches up right there? That's our east to west profile of this topographic map. We're going to take a look at this map right here next, Wildlife Preserve number 2. And you can see the contour lines are pretty close together on this side. And it goes up quite a distance. There's a lot of contour lines. We're going up quite a distance. And then we're coming downhill, and then we taper off over here. So these get further apart. So it's sort of like a gentle round off over here. So when we look at our profiles, this one has 2 hills. That cannot be it. This one has one, but it drops almost straight off over on this side. So that really wouldn't be our ideal profile. This is a nice gentle hill, but that's not what we're dealing with either. On this one, it goes up, 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 and then it drops down a little bit, and then it falls right off. So this one could be our profile. But when we look at this one, it's got this, it goes up, 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 and then it sort of tapers off. This one might be our best pick. Let's take this over here, and we're going to take a look at it. Okay, so this, it goes up and then tapers down. So this profile would actually fit this topographic map. Now in this one, this has 2 hills, and in our profile selections, there's only one profile with 2 hills. So we kind of know which one this is. So we'll bring this up here so we can see it. You can see here, these are closer together, and then they get further apart. And you can see that steep climb, and then it gets a little more gentle. And then here we come down, and there's a valley that's pretty wide. And then we start to go up to that second hill, and then we fall off on that other one over here. So we have this nice wide valley, and then sort of a steep descent over here. So those are our topographic maps with their east to west profiles, which is what you'll be looking at in 1.05 topographic maps. And if we looked at a north-south profile, on this right here, we could see that we have a sort of a gentle incline, and then we have, I think this one is going over this hill where it's nice and steep, and then it comes down and it's dropping, but it's not dropping straight off. It's sort of an angled drop. And so I think that one would look more like this because the hill is not too high. So it would look more like E. On this one, though, if we go up, 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 and it's not too bad. It's a steep incline, but not too bad. We get to the top of the hill, and then right here we're falling very quickly because these lines are almost one on top of the other. So this is going to fall steep, very steep, more like profile B. And then if we go north-south on this one, this is just a really gentle hill. This one doesn't have a big mountain in the middle, so this would be our profile C. So when we look at a topographic map, we have what we call our contour lines, and the ones that are labeled with a and elevation are generally darkened, and those would be called our index lines. Okay. We also have a distance of rise or descent in elevation between each contour line. And we call that our contour interval. How much do we go up or down in elevation between the contour lines? This one is 50 feet. So what they want us to do is label each of these lines so that it shows a 50-foot contour interval. Okay? And the way that we do that is we label, this one would be 50, and I'm going to use this slash right here, and I'll make this 5 a little bit more visible. Now we take 50 here and we add 50 to it to get to this one. So this would be 100. Okay. And then we come in another contour line. So this one would be this is 100 plus 50 more feet in elevation. This would be 150 feet, that circle. And then we come in another contour line. Both of these are the next innermost contour lines. So they will be labeled with the same elevation, which is 150 feet plus 50. So this becomes 200. There we go. And this one is also 200, like that. Now, if we want to find the change in elevation, what we do is we take a look at the contour lines and we subtract the elevation of one to the other. So let's say we wanted to find, let's label this line A, and then we'll label this one C. We want to find the change in elevation between A and C. What we would do is we would do A minus C equals our change in elevation. And so A is 50, I'm sorry, we would reverse these. So it would be 50 feet, and this was 150 feet, and this is A. And so we would do C minus A, and that would equal our change in elevation. So C would be 150. Sorry for the rustic drawing, guys. Minus A, which is 50 feet. Put our units on here. This little dash means feet. And we do 0 minus 0 equals 0. 5 minus 5 equals 0. And 1 minus nothing equals 1. And then we bring down our units, which is feet. So the change in elevation between A and C is 100 feet. Okay. And that's how we find the change in elevation using the contour interval. The other way to do that is to count. Okay, so A here, then we have, so we go 50, 100. We just count by 50s because that's our contour interval. And we count each contour line. So we're counting by 50, each contour line that we hit between A and C. So we go again, 50, 100. That's our change in elevation. Okay, so 2 ways we can find it. So we are going to have to switch to a new video to do topographic maps part 1 and 2. And I'll see you guys over in the next video.